So now in this video we're going to look at another circuit here where we have an LED that is fading on and off. To get our changing voltage, we have a 555 timer wired in astable mode, but the voltage is not coming from the output. We have the capacitor that charges and discharges while it's in astable mode, and we are transferring that voltage that the capacitor is to the one side of the LED. But the capacitor cannot provide current that would throw the voltage off. So we have an op amp wired as a voltage follower. The op amp that we're using is the LM358. There's two of them on the integrated circuit. There's number 1 over there, number 2 over there. We're using number 2 out of 2. And we have the non-inverting input plus, which is the bottom pin, coming over here. So that is where pin 2 and pin 6 connect, but it's also where the positive side of the capacitor is. And so it takes that voltage, and the output is tied directly to the inverting input, which is up one more spot there, and the output does whatever it can. It raises or lowers its voltage until the voltage at the inverting input is the same as the non-inverting input. So since they're directly together, there's nothing to shift the voltage. Whatever the non-inverting input voltage is will ultimately be the output voltage, because that will hold them the same. That's the goal of the op amp. Now you can see that the LED is being powered from the positive supply up there. So actually when the LED gets brighter, that means we have a lower voltage at the output. Alright, hopefully planes are done flying overhead now. So we have the capacitor. This 555 timer does the timing. We're not using the output though. We are just looking at the voltage of the capacitor. So it charges through that resistor and goes around this resistor thanks to a diode right there. So we're only charging through one resistor. Well, the voltage goes up. The output voltage is going up. So that's actually when the red LED gets dimmer, because you can see we have the full 5 volts right there. So it's probably going to get up to close to 3.5 volts or so. And then we don't have enough voltage difference to really light the LED. The LED will basically be off. So it charges, and then pin 6 sees that it's 2/3 of the way. So that's why I just guessed, approximately 3.5. Then the pin 7 is going to drop to ground. And it's basically a switch. Connect to ground, and whatever current this or that resistor just goes down to ground. Doesn't affect the timing at all. Then the capacitor discharges through that resistor, which is the same value right there, and keeps discharging till it gets to 1/3 supply voltage. So as it gets closer to 1/3 supply voltage, the output here of the op amp is the same voltage because it's following it. It's not taking any current though. No current goes in or out. It's just outputting the voltage independently. So it's providing the power. Capacitor doesn't have to, and so it's not affecting the timing of the capacitor. But as the capacitor discharges right there, its voltage goes down. There's a lower voltage here. That's the highest voltage there. So there's a bigger voltage difference. The red LED keeps getting brighter until that gets to 2/3 supply voltage, or to 1/3 supply voltage. I mean, we got pin 2, and then it stops discharging and starts charging again. And now we'll take a closer look at the physical circuit. So we have to power the 555 timer, positive, negative over there. Just going to kind of quickly rush through this. There's our charging path, and then we got the diode, so the gray band, the cathode's over there, so it can charge that way through the diode. And then when we start the discharge process, it can't go through the diode. That'd be current going the other way. It's got to go through that resistor. So pin 6 starts the discharge process. And our signal over there also goes to pin 2 and also to the non-inverting input, the plus over there. When pin number 2 senses 1/3 supply voltage, then it stops discharging and lets the capacitor charge again. We're not using the output of the 555 timer, so we're not worried too much about what that's doing. Pin 4 is the reset pin. We don't want this to reset. If we reset, it will stay low, but also the capacitor will just keep discharging until it's completely discharged. That would mean the LED would just be on constantly in that case, fully. And then we got our inverting input there directly to the output, 1 pin up there, and our load. So again, when the output is low, connected to ground as good as it can, you have to power the op amp. Then we will have that current path. The red LED will light up. When the voltage is close to 5 volts right there, then the LED will not light up because you won't have much voltage difference, as you can see there. Now I did intend to use a resistor here. Again, we're not getting current moving from the capacitor. So you could just use a resistor like that to bridge the gap as well. That's a 10K resistor. But I forgot to draw that on the schematic, so I didn't show it through most of the video.